Here is the question number 16. The following figure shows a solid of uniform cross section. Find the volume of solid. All measurements are in centimeter. Assume that all the angles in the figure are right angles. That diagram or the question is quite easy. First of all, we are going to do partition. Divide that diagram into two parts. Divide that diagrams into two parts. The first one is this one and second one is this one. For the first one, for the first cuboid, we are going to take the length 9, breadth 3 and 4. For the first cuboid, we are going to take the length 9, breadth 3 and height 4. And for the second cuboid, we are going to take the length 6, breadth 4 and height 3. First of all, divide the entire diagram into two parts. Cut from that side. This is your cuboid 1 and this is your cuboid 2. And here is the length 9, breadth 4, height 3, length 6, breadth 4 and 3. Okay. So we are going to divide the cuboid into two parts. Then apply the volumes formula and then add. Okay, it's quite clear. So first of all, given figure can be divided into two cuboids of dimensions 6 centimeter, 4 centimeter, 3 centimeter and 9 centimeter. Okay, so for the first one we are going to take the length 9 into 4 into 3, and for the second we are going to take into 6 into 4 into 3. Okay, so for first one, 9 4s are 36, 36 3s are 108, this one, and for second 6 4s are 24 and 24 3s are 72, and then do add. It's 180 centimeter cube. The question is quite clear. And let's move on to the question number 17, which is a case of swimming pool. A swimming pool is 40 meter long. This is a swimming pool and it's 40 meter long and its width is 15 meter. Okay, swimming pool which is 40 meter long and width is 15 meter. It's shallow and deep ends. Shallow and deep ends. Here is the shallow end and deep end. Deep ends. Okay, where I was. Its shallow and deep ends are. Shallow end is 1.5 meter and the deep was 3 meter. If the bottom of the pool slopes uniform, bottom of the pool is uniformly slopes, find the amount of water in liters required to fill the pool. We have to calculate the water, amount of water in that swimming pool. Amount of water in that swimming pool means I have to calculate the volume. So let's start. Here I have this shape, and first of all it is in the shape of trapezium. Okay, trapezium, and we know that the formula of the area of trapezium is half sum of parallel sides into height. Okay, half sum of parallel sides into height. So area of cross section of the solid is equal to area of trapezium, that is half sum of parallel sides into height. Half sum of parallel sides, that is 1.5 and 3. 1.5 and 3 sum of parallel sides, 1.5 and 3 into 40 into 40. So we are going to cut this one. 2 1s are 2, 220 is the 40, and this is going to be at, which is 1.5 plus 3.0. Okay, because we have one number is in decimal form and second is without decimal. Okay, so I can write 3.0. So I have 5.4. So it's 4.4, which is going to multiply by 20. Here I have 90.0 meters square. Let's move on to the next. Now the volume of solid. How you calculate the volume of solid? If you want to calculate the volume of solid, that means length into breadth into height. Length into breadth into height. So length into breadth is the area, which I already calculated, and the height is 15, and the height is 15. So clearly in the diagram the height is 15 meter, which is already given to us. Okay, so we are going to do the multiply. This is your width, so we are going to do that multiply. 19 into 15, that is 1350 meter cube. It's meter cube, and they asked to find the volume in liter. So remember that there are 1000 liters in 1 meter cube. In 1 meter cube there are 1000 liters. Meter cube is the bigger unit and liter is the smaller in comparison to this one, and 1 meter cube consists of 1000 liters. So we are going to multiply here with 1000. So 1350 into 1000 liter, we have 13,50,000 liter, or in international system we can say that we have 1,350,000 liters. Okay.